This is a bonus video on accumulation functions. This is kind of showing the fundamental theorem of calculus. I referenced this video in the accumulation video, part 1. So what I'm going to do is work with this integral. I want to find the derivative of this accumulation function. So I'm not going to use the fundamental theorem, part 2, first. I'm going to first just do it how I would normally. Now, the first thing is that I want to find the antiderivative of each one of these. So I can find the antiderivative of here. This stays the same, sign stays the same, and I'm going to write this t as t to the 1/2 dt. So I first want to indicate, I want to find the antiderivative of this. So this now becomes t to the 3rd over 3 minus antiderivative of negative sign is going to turn out to be positive cosine of t. And then I do the power rule on t to the 1/2. So I add the power by 1, 3 over 2, all over 3 over 2. I'm going to have my lower limit stay 1, upper limit is going to be x. So what I'm doing is using the fundamental theorem of calculus part 1, finding my antiderivative, and then keeping my upper limit, my lower limit. I can simplify this some more, t to the 3rd over 3 plus cosine of t. This 3 over 2 reciprocates to a 2 over 3, and it's t to the 3 over 2. Lower limit is 1, upper limit is x. Now I want to plug in my x, so it's going to be x to the 3rd over 3 plus cosine of x plus 2 over 3 x to the 3 over 2 minus, now I have to plug in my lower limit into the entire expression. So it's going to be, well, when I plug in 1, it's going to be 1 cubed over 3 plus cosine of 1 plus 2 over 3, and then 1 raised to the 3 over 2. So this really is what h of x equals if I were to take the antiderivative and then plug in my upper limit and my lower limit. But I wanted to find the derivative of this. So now I want to find h prime of x. So if I find the derivative of this, finding the derivative of this big old expression, x to the 3rd over 3 plus cosine of x plus 2 over 3 x to the 3 over 2 minus 1/3 plus cosine of 1 plus, well, 1 to the any power remains 1, so 1 times 2 over 3 is just going to be 2 over 3. And I want to find the derivative of all of this. Alright, so this derivative is the power rule. It's going to be the derivative of x to the 3rd is 3, x squared over 3. The derivative of cosine is negative sine of x, and then plus this derivative is the power rule. This is the constant times the derivative of this, which is 3 over 2. Subtracting this power by 1 gives me 1/2 minus, all of these terms are constants, so all of these derivatives just turn out to be 0, so I don't have to worry about all this. So I can just stop right over here. And then when I simplify h prime of x, this is going to be, well, the 3's reduce out, and I just get x squared. This negative sign just drops down as a negative sign. And these two fractions are reciprocal, so this reduces completely, so I just have plus x to the 1/2. And this just becomes x squared minus sine of x plus square root of x. Whew! Alright, so all this work just to end up back where I was initially. Because really what I could have done for this problem, had I used the fundamental theorem of calculus, was this integral and this derivative cancel out. And you can see that all I would have to do after I cancel the derivative and the integral is just swap in x for each one of these variables. So x goes in place basically of t. So my derivative is going to be x squared minus sine of x plus square root of x. So the fundamental theorem of calculus part 2 skips all of this work, because when you take an antiderivative and you take a derivative, the two undo each other and you end up at the exact same place. However, this is maybe a 5-second problem, and this is close to like maybe a 5-minute problem. So hopefully after seeing this video you recognize the power of the fact that a derivative and integral cancel each other out. And that's it.